Okay, so this is the Module 3 lab activity. It's the Lunar Phases Lab. Here's your little splashdown page. Again, I recommend that you open your student guide in a separate window, or even print it out if you wish, so you can work on it while you're going through the simulation. The first few pages are actually all just background page material, and I'm not going to go through it question by question. Again, they do point out which page you should be looking at, so notice that the background pages are numbered. So there's page 1, that shows various names of the moon phases, etc., etc. The orientations of sun, moon, and earth to create the different phases. This is very similar to some of the diagrams you're going to see in your textbook. One thing I will point out on page 2 of your student guide is that you're supposed to first of all name these various moon phases, A, B, C, D, E, F. Come up with a name. And then also it says identify the phases and put them in the correct numerical order that they would appear over several weeks. So they're saying, okay, we're going to start out with the waning gibbous phase. And then you're supposed to determine of these other phases, which one would come next, which one would come next, etc., etc., and number them. Now, I'll also warn you or point out that 2 of these phases are actually the same, or 2 of these pictures are the same phase. Notice that A and F are indeed the same phase. They're just different. They're both a crescent phase, but one is more crescent than the other. So you've got to determine which one might come first. And you're going to put those in their positions, their respective positions, in this diagram down here. So again, continue on through pages 4, 5, and 6 of your background material to answer the rest of that. Now we're going to get into the actual simulations. So we're going to back on out and get to the moon bisector demo. So that's what this first on page 4. They describe that. You're supposed to essentially play around with the moon bisector demo. And the moon bisector demo, what it does is it shows, first of all, you put your sun in here. Now the sun, of course, is off to the left. Then you add in some bisectors. What those bisectors do is they divide your moon and your earth into a section that's being illuminated by the sun. Notice my sun is coming in from the left, so therefore the left side of the earth is lit up, the left side of the moon is lit up. The right side of the moon is dark. The right side of the earth is dark. We're essentially seeing the daytime sides and nighttime sides of both of these bodies. Then you connect a line, you shoot a line that connects the earth and the moon, and then you show the bisectors. Now this cuts the earth and the moon into sides that can be seen from the other and sides that can't be seen. So for example, this is the side of the moon that can be seen from Earth when the moon is in this position. This is the side of the moon that can't be seen from the Earth. So we've essentially established of the part of the moon that's being lit up by the sun, how much of that lit up part can we actually see from the Earth? And you can play the game vice versa. You can also say, okay, what if I was standing on the moon? What would the Earth look like from this perspective? Once you've kind of figured that out, then you can actually check your answer by showing the moon phase. So in this case, this is a 3rd quarter orientation. So that's how the moon bisector is used. And you'll use that then to answer the next several questions. Now eventually you're going to get to this chart. This is on page 7 of the student guide. I recommend you use the lunar phase simulator for this one. Again, it's very much like the moon bisector. It's the same kind of diagram. You can move your moon wherever you want, make it go through all its phases. And the questions you're being asked are, what's the age of the moon? What's the phase of the moon? What's the percent illumination? My recommendation, notice all these different diagrams over here. You probably want to turn your paper so that your sunlight is always coming in from the left side, just the way the simulator is set up. Then, once you've done that, once you've shifted your paper, then try to get your moon, earth in the proper orientation to match your diagram. And then you just write down, and then once you've done that, you'll write down the age, which is shown over here, time since new moon. Write down the phase, in this case, the waxing crescent, and then also write down the amount of illumination, and that's it. So that'll get you through page 7. Page 8. They ask for the rising time, meridian crossing, and setting time for various moon phases. So again, you can do that using this this simulator. Again, you can choose various moon phases that are in your list, and then determine, okay, what time would that moon have to rise. So notice in this horizon diagram, it shows the position of the sun as well as the position of your moon. You know, of course, this is local noon. You know, the observer time is at 12 p.m. But you should be able to click on through here and determine what time your moon, what time it rises, right? Approximately. And then, you know, when is it crossing the meridian? Remember, the meridian is this imaginary line in the sky that divides your sky into an eastern half and a western half. It goes from the north point through your zenith and then through your south point. And that's all it's asking for, is the meridian crossing time and then the setting time. Okay? So that'll take care of the table on page 8. And then finally, on page 10, we're essentially, page 10 is the last table and the last few questions we're going to answer. For that, you're going to use the next simulator, which is called the Moon Phases and Horizon Diagram Simulator, which is, again, just a little closer view of the relative positions of the sun and the moon in the sky for your various phases.